Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Question answering with Huggingface Agents and Weaviate vector store. Future of LLM plus QA pipeline with open source agents and tools. I'm going to dive directly into the pipeline or the flowchart that we'll be using for this particular discussion. So you see there are two starting points. One is the text data that you will be working with, and another is the Huggingface agent that will be the large language model. So what will initially happen is you will have a text data. It could be of any kind of document that you are having that is converted to text, and then it is split and embedded using any of the open source available libraries using sentence transformers, and then it is stored in Weaviate vector store. After that, the things start becoming a little bit different. So what will happen is you will be using your Huggingface agent and you will be asking it some question, right? You will be expecting that you give the question to the agent and it does something. So for that, what will happen is we have to understand the question answering variables that is available inside the Huggingface tools. I'll be showing you what exactly is happening here, and then the user question has to reach, it has to go to a kind of a common Python function where the Python function takes the question, that is a user question from you, and it also connects with the Weaviate vector store and gets the necessary text, that is the similar text with respect to your question. It tries to get it from the vector store and then gives it to the agent for it to answer it. So this is kind of a two different entities, that is the LLM and the vector stores are trying to work together. So that is why you see this kind of a little bit complicated activity that is going on. In case of if you take a look at the various other libraries like LangChain, if you are working with Llama Index, what happens is they have internal libraries and methods that actually abstract away all this from you. So this entire process that I'm doing here has been already implemented by the developers of those libraries, and you don't see this. But however, in case of Huggingface agents, this is the process we need to follow. As I am talking about this, LangChain might have already developed this kind of a framework already. So I am not sure about that. And being open with you, I need to still try to understand what kind of primitives LangChain development team has implemented, right? So that, with that said, I always talk about the challenges that is getting solved, right? Here, what is the challenge that is solved is using open source large language models and vector stores, again open source vector stores, to answer questions from your user documents. This is the primary challenge that is getting solved here, and it also try to provide a conceptual understanding of how the agent prompt, the vector storage, and the final retrieval works. So both of these challenges are taken care in this particular discussion. So you will have, it's not going to be just about take a user question, get the similarity search and get the answer from the agent. It doesn't work that way when you are working with open source models, because you have to be a little more patient with the large language models because you have to give more information to these open source models. So we will see how to do that. That is the primary reason why I have this separate step where you as a user or you as a developer need to understand what kind of input you have to provide. All this will be discussed in this particular Jupyter notebook that is already hosted on GitHub repo. You must be knowing my GitHub repo, or else I'll be showing it in a couple of minutes. The most another one of the important point I always talk about is practice. Whenever you see this red slide, you must be already programmed that okay, Kamal is going to talk about practicing. And yes, I will be requesting you to subscribe to my channel. I believe that you are liking the content that I am making and the way I am trying to present the challenges and the solutions to it. Because I am facing these challenges, I do a lot of research and then try to come up with the optimal solution that I feel it will be useful for you also. Going to the browser, if you are new to Weaviate, if you are new to Huggingface models, how these things work together, then I have a series of videos inside this particular playlist where I discuss about Weaviate, and I also discuss about the Huggingface models and how the embedding works, etc., etc. right? I'm not going to go into the details of those steps here. I expect that you guys can actually take a look at these videos and come up to speed. I have made it as easy and simple as possible. Even if the videos are sometimes you are unable to follow, each of these videos have its own necessary code Jupyter notebooks that you can download it and practice it by yourself. This is one of the main reason why I always insist on creating setups that you can easily practice. So as I was telling, the conceptual understanding of agent, prompt, vector storage, and final retrieval, all this has to be understanding at the level of concept is one thing, but putting that concept to use, implementing that concept in your own programming, in your own challenges, and then trying to find the solution is the best way to understand, and that comes through practicing, guys. So that is the reason why I make these kinds of notebooks and share it with you guys. And also thanks to Google Colab that I am able to do all these things. The other day I was thinking, if Google Colab was not there, then I wouldn't be able to share all this. I wouldn't be even able to practice for myself these concepts that I'm sharing with you guys. So it's a huge shout out to Google Colab for being helpful for the community. Now, with all that said, let us go to the GitHub repo. So this is the repo, and this is the particular notebook I'll be sharing with you guys. It's already shared. It's already available there. Let me go to the, I'm going to close this so that we can go to the Jupyter notebook, Colab environment. I've already loaded the same notebook that I showed to you in GitHub repo right now. What I've done here is, you might be confused that by looking at these 3 or 4 libraries here, that what is LangChain doing here, and why are we having sentence transformers. So I'll be going through this step by step, because first and foremost, this particular notebook, you have to use Huggingface API keys for accessing the Huggingface agents. If you are new to this particular Huggingface agents concept, the tools that is available with Huggingface agents, I would suggest that take a look at my earlier video on Huggingface agents. You will come up to speed really fast. And also there is an associated notebook with that particular video also. So I'll be attaching those things with this video also. With that said, you have to log in using the Huggingface token, that is a read token. And then why I have LangChain here is that I use the recursive character text splitter. So I like this particular class primitive from LangChain, because it helps to easily split the text documents that you have. So I'll be using one of the text document called as mail collector. This is part of also the repo. So you can find it out in my repo. It is available in the projects folder. You can locate it very easily from the GitHub page. I use that text document and I send it through the recursive character splitter and split the text. So that's what I'm doing. And for that, I have already created a simple function where you have to just send the path of the text file and you get the split document. This is why I use LangChain here. I'm not going to use LangChain other primitives in this particular video. Yeah, I have a very different way of approaching the problems. Wherever it is possible, I try to use the open source libraries, open source methods and functions. It helps to avoid repetition. I can actually create my own simple text splitter. It's not going to take a lot of time. However, explaining the logic that I used in my text splitter is going to be a little more longer. It's going to take longer time. But all I need to do is, in this case, I'm just telling, okay, recursive character text splitter is from LangChain library, and the developers in LangChain library have done a great job. So you must be knowing that they have done an efficient way of splitting the text file. That is the reason why I'm using this. So I hope you understand the reason why I'm selecting it. And here comes the embeddings. Embeddings are the ways to interact with the tokenizers or the open source embedders. Let me go to the PDF presentation, because this is something that we need to understand a little bit deep. We have a text, so now we know that we can split it. But after we split it, in order to make it fast for vector storage and retrieval later with similarity search, you have to convert the split text into vectors. This is a concept that I've explained numerous times in different videos, and I am not going to go deep into this. So what I'm doing is I'm going to use Huggingface embedders only. and I'm going to embed the split text, and then I'm going to store it in Weaviate. All these two steps will be done together inside Weaviate. So here I have split it for understanding. But if I go back to the browser, it is asking me to reconnect. Let me close it. It's not required to reconnect. I am going to use the embedding, but here what I am doing is I am initiating the embedded option. So this embedded option is Weaviate embedded instance. So you see this embedded Weaviate is already listening. So this particular line will create an embedded Weaviate instance, and this particular line here you need to provide the Hugging Face read key. So ensure that you provide this here. This particular read key is going to help you to create the embedding. Keep this in mind. This particular location where you are going to give the HF read key will help you in doing the embedding of the vectors. But if you go up, you see I am using a login call here, right? This particular login call is going to be useful for creating the agents. So there are two places you will need to give the same Hugging Face read API keys. One is in this cell and another is in this cell. So there are two places, right? Once you do this, then next you need to create a schema. So here I've just created a schema where I use sentence transformers, all mini LM L6, and I'm going to use the property called as raw, and the data type is text. So this is a way of creating schema inside the Weaviate vector stores. Once that is done, I'm using the get text splits. I am giving the mail collector document, mail collector text. So I'm going to reconnect it just to avoid some kind of sudden requirement. And so here you see that I have already the mail collector text file, and then you see this particular splitting has created multiple documents, and this multiple documents are going to be loaded. So this is where I am loading these kinds of documents into the Weaviate vector store. Let me see. Yeah, it is already up and running. Yeah, it is already up and running. Right now, they had this particular collab notebook gives me the virtual machine itself. So it's not an instance. It's not a Docker instance. It's a full virtual machine. So that's why they go into standby if I don't use it. Coming back to the discussion here, we were discussing how this particular documents. So let me see how many documents are there, just for and showing you what is going on. If you see here, there is going to be 50 different documents. So this particular text file. So let me open this text file also for you guys to take a look. It's basically a collection of mail text, mail body, and mail subject. I have been using this particular document for other videos in my series, and this particular document has been split into smaller chunks of text. Next, what I'm doing is I'm just taking those chunks here, you see this, and I'm going to send it into the Weaviate vector store. I need to provide this particular format, and I'm giving this sleep so that my HF Hugging Face API inference endpoint don't time out. So I am just giving that for that purpose. Once that is all added, all we need to do is, again, this particular Python function is what I was talking about in this area. So sorry about the typo error. I meant Python function for retriever. So this is the Python function for retriever that I am talking about here. So this particular function actually takes the question that you are going to provide, and it is going to use the concept called near text inside the Weaviate. And see, I am taking 5 results from the Weaviate vector store, the vector similarity search result, and then I am doing kind of a small for loop so that I can take the text data from the storage, from the return storage, and then return the final text. So here, if I will show you how the final text will look. So I am going to do a vector search for photographs taken. So this is the question that I am sending it to the vector store, and if I look at the updated result, you will see that it is a paragraph of text. It's a simple paragraph of text that has been collected from the Weaviate vector store. You can actually try this out one more important point, I always insist that you have to break my examples. The notebook that I'm providing, you need to try something, some other text file that you are having, or some other way of changing the connection that I am implementing in this for loop. You need to try something different so that you start getting some errors, and then you need to correct it. That is how you can actually learn really fast, and that's how I also learn from various other sources that I get. Okay, coming back to the discussion. So we have the text collected. Now, this is one of the points that I got really stuck when I was trying to create a QA pipeline with using Huggingface agents. What is happening is, in case of Huggingface agents, there is a kind of a prompt that is already built into the Huggingface agents, and this prompt, this is a template that I'm showing. So this prompt the agent prompt will have an introduction, and then it will start with the tools. So you need to provide the set of tools that is already available. This is an example I am showing here. I will not be using this prompt template, okay? And then I need to provide an example of tasks and its respective answers. So if you take a look at this particular task here, so you see this line, answer the question in the variable question, and the text in the variable text, okay, and use the answer to generate an image. This particular line actually has a lot of information, and if you don't understand, or if you don't read this line, then the next step we cannot proceed. So this was a mistake I was making. When you're going to give a task, or when you're going to give a prompt to the agent, Huggingface agent, you need to have three variables. That is, you need to have a task, you need to have a question, and you need to have a text. You see this: task, text, and question. If these three are not there, then this particular function, this is a tool that is available inside. So this is a tool that is available inside the agent that is already loaded, and this tool will not get the necessary information. So this tool cannot execute. So initially I was facing this problem, that if I don't properly give the task, if I don't properly give the question and text, it was failing. And it took some time for me to understand, until I went into this particular prompt and started digging deeper. And then I created this particular agent. So it's a simple star coder agent from the big code. And then here you see the task. The task is a simple one line task that I'm asking. This you don't need to change. So this is something which is going to be common, because this is a QA pipeline, right? And I'm going to ask, the task is to answer the following question. So I'm not telling anything else. I'm just telling the LLM to answer a question. And then I give a question variable. And in the question variable, I ask how many photographs are taken. This is the question I'm asking. And then I'm giving the necessary text documents. And then I'm returning the code. So I'm showing you here an example. So how the question, text, and the task works. So you see the text, the question has been loaded here, and the entire code which will get executed by the agent is shown here. And then after seeing that, I execute this. So once I execute this, you will see that it actually goes to the task, it sees the question, it looks at the text, and then it tries to answer. If I don't give any of these variables, if I for an example, if I remove this, I just want to show you how to break it. I think this might work, but let us see. Okay, so in this case, the question and the task was the question and the text was very clear. So let us do this. Let me create a little bit bigger confusion, and let's see what happens. Because the idea, anyway, now it is, so agent.run takes 2 positional arguments, but 3 were given. Now you see that some kind of new error has come. So agent needs 2 positional arguments, but 3 were given. You might be wondering, Kamal, just a moment back, the agent was able to work with 3 positional arguments. But why is the error showing me, why is the error telling it can take only 2 positional arguments? So these are the challenges that both the Huggingface team is also working. As Huggingface team has already told, the agents library or the agents primitive, HF agents primitive, is still in development. They are also working on all this errors and type of replies that comes. So Whatever you see here might be a little bit different when you actually watch this video. You might watch this video down the line in 6 months after this video is made, and the entire agent primitive might be totally changed in Hugging Face. However, please remember how they have implemented at the beginning and how the changes have happened. In this way, you can learn from the start, and you can actually implement a very robust QA pipeline for your documents and your application. With this, once I actually establish all these three variables, the result comes out, and you see that it still works with 3 positional arguments. So it is not giving the error that it can only work with 2 positional arguments. So you see these kinds of, the errors are not very directly informative. So you have to understand what the agents will do based on the prompts that has been provided. And how did I know about that this prompt is available? It's very simple. It's actually you have to just use this. Let me show you. So it is just a attribute of plain agent. If I use this and if I ask for run prompt template, you will immediately get the prompt template. So you see this, and if you execute this, you will see the entire prompt template that Hugging Face team has used for this particular agent. And if the same way, if you do for chat prompt, the earlier video that I was explaining, that I was telling about the agents and tools. So you see this is a chat prompt template, and it's very simple. So this is not a chat prompt, right? This is, I am using Hugging Face run prompt. So that's why I'm not getting this. But if you are having chat prompt template, it will work like this. So human and assistant. Now we know how this works. What we want is, let us go back to the PDF. I have explained that this particular Python function or the retriever is going to take the data from the Weaviate, and it is going to take the user question, and it is going to provide the reply to the agent, and the agent answers the question. Correct? So it has to do a couple of things. First of all, it has to retrieve the text. So it will take the text from the Weaviate vector store. Then it has to take the user question. So how is this going to be done? Let us go back. And if you go to the this particular function that you see here, it's a pretty simple function. I give a user question. That is a question that comes from from you, and I first take it to the text docs, get text docs, which is the function that takes the necessary that is connected with the Weaviate vector store. So you see this. This is connected to the Weaviate vector store. It returns the text as paragraph, and then what I do is where it is. Just give me a moment. Then what I do is I create this this particular call. The call has this same task. Task is to answer the following question, nothing else. And then in the question I give the user question, and then in the text I give the text docs that I get here. In this way, what will happen is, whenever I'm going to ask a simple question, so I use a agent QA function call to the Python function call, and I say the user question, how many pictures are taken. So you see what will happen. This particular how many pictures are taken will go to the text docs. Okay, it will get me the text docs, and then this text docs will be passed to this call, this run call, and then the question, the user question will be passed here, and then I will get the answer. So you see the answer is getting replied here, and this is one of the another question that I have placed, and here you see that it is also transferring it is giving an example of what documentations are getting returned from the Weaviate vector store. So this is something that I have kept it here so that you guys can understand what is going on, right? And then you see the answer. The sky has to be clear. Obviously, if you are going to take pictures of stars that is far away, then ensure that your sky is well clear of clouds. So in that way, you will have good result, right? I hope that by now you must have got some clarity on what exactly is going on when it comes to the Hugging Face Agent QA pipeline. So the text that you are having goes as a separate steps and converted to embedding, and then converted to Weaviate vector, stored in Weaviate vector store. And then there is another one series of steps that is going on with respect to the Hugging Face agent, where the user question is used to collect the data from the vector store, and that both the user question and the data is sent back to the agent for answering. So I have come to the conclusion of this particular small introduction. I wouldn't say it's an introduction. We have seen a lot of important concepts related to vector store, related to Hugging Face agents, related to the variables that you need to provide to the agent for getting a best result. So do practice a lot, because once you start breaking these examples, working with the same type of variables, same type of scenario is pretty simple, right? You have to try something. You have to try a different tool. In case of Hugging Face agents, there is around 10 different tools. If I am not wrong, there are 10 different tools which can work with images, which can work with audio, which can work for translation, and various other, and also you can make custom tools also. So I have discussed about that in the earlier presentation. Try those things along with this with text QA, and see whether you can chain the tools together. So take the information from the text QA, send it to an audio tool, and see whether you can get the audio output of the text QA. So that is one of the next steps you can try, because once you try to chain couple of steps inside the agent, you will start facing challenges, right? Because the output of one agent has to go in, output of one tool has to go into the next tool, and each tool have their own variables, and you need to create the prompt in such a way that each of the handover from one tool to another tool is done with proper variable names. This is one of the key points that I wanted to highlight again and again. So in case of Hugging Face agents, they are pretty new, and they are very primitive. It's not, you cannot compare them with very large language models like GPT-4 or GPT-3.5. They are huge models, but Hugging Face models that we are working with is extremely efficient, and they are small, and they have been trained for a particular task. They have not been trained for doing thousands of tasks. They have been just told, okay, follow a particular task given by the user, nothing else. They don't have a huge amount of they are trained on huge amount of data, but the way they are trained is to ensure that their size is small, they are efficient, and they are really fast. So with all this said, I believe that you like this video. Do leave a like and share it with others. Subscribe to my channel for further updates similar to Transformers agents, Hugging Face agents, and also the Python ecosystem surrounding large language models, and the overall the overall domain of problem solution with respect to large language models. With that said, I would like to leave this video with 4 words. That is practice, 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 practice. See you guys. Have a great time.